let's discuss on the very high level architecture of this MongoDB application itself. So let us assume that there is a web application which needs to retrieve and store the data in real time. And to connect to the backend, this application needs a driver. So which is the component, which is a Mongo component, which will actually connect with the application. And then there comes this router. Router is like a middleman who actually bridges the flow from the front end to the data store itself. So underneath the router, these concepts like primary and the secondary, those are all actually not visible to the naked eye, but we can see some informations like which machine is a primary machine and which are all the secondary machines. So those things can be identified. So this router actually what it does is it helps in distributing the data across multiple machines. So this primary, like we can see that 3 arrows pointing to primary, and then secondary. Here I've just mentioned a very small cluster of machines, but in real time we will be having a very huge number of clusters and machines will be in place. So even people consider it as one of the disadvantages, like to maintain all the machines actually little challenging part. But when it serves the data, what not to do, that is what the case. So the router actually shards the data. So over here you can see actually I missed to add that, like we will have shards over here. So these shards will be placed under each of the cluster of the machines, and so this is what we call as the replication part, and the data will be distributed across each of the machine. And whenever the request comes, it will come in this fashion. It comes to the application, gets connected with the driver, goes to the router, and then it fetches the information, and in turn it comes back this way and shown to the application. This is the very high level architecture, but it has multiple things under the hood. So each one, even the router has its own flavors, like driver, like I've just mentioned a single driver, it has multiple drivers for multiple languages. And even sharding, when it comes to sharding, we have different methods of sharding, like hashed sharding and one type sharding. Many types of sharding is there. For based upon the scenarios, we'll be defining the sharding part, and that is how we retrieve the data in a very easy and fast way for the complex query patterns. So I'll be discussing about real world use case, how a chatbot is using a MongoDB to store and retrieve the data. So we know that now chatbots is like way replacing many of the human beings. Like it is helping in getting the question and answers served for easy questions which human is actually not required. So in that place, like chatbots are way used, and I'll just go through the sequential flow, and in the next slide I'll just show how it is actually implemented. So imagine there is a chatbot, and let's consider in this case travel, or not even travel, like in the current situation, people, we are very much suffering from this COVID situation, and we are getting a lot of fake informations. So in order to avoid that, we have a chatbot, and that will answer most of the queries related to COVID vaccine. So this chatbot will have a service that is like, this is the front end piece, which can be of any channel, like it can be a web-based chatbot, or third-party applications like Facebook Messenger or Line Messenger, or even Google Assistant. So this can be plugged into any of the channels. and which in turn goes to the request are being made to the server, which is actually hosted in the cloud. This this web framework will collect the request and then it will do some processing on top of the raw data, and then it is stored in the data store, which is our MongoDB. The questions can be of any form. It is not very static questions. So it can be of any different types of questions. Sometimes it is not even necessary for user to even provide a question which was asked by the chat. So in that case, the schema need not be same. It can be of different schema. So that is the real purpose of having the MongoDB itself. And then will be there is a visualization made based upon the queries and the performance. So this is with respect to one real world use case. And the credits to the image, each of the image was collected from the Wikimedia, and credits to each of them. A small demo, but here I'll be just showing you how I have actually loaded the data and how I'm just visualizing using the Mongo Compass, which is the GUI, official GUI provided by the MongoDB itself. So I've used a programming language called as Python, and I've used a web framework Flask to insert the data, to retrieve the data, and to even update the data. Sorry, my screen is actually stuck, and I'm just trying to go into a script called as Mongo Connection, wherein I can show you how I've just created a connection and then how I inserted the data at first place. Okay. You can see that there is a library called as PyMongo, so which is the third-party library which actually helps Python to connect to the MongoDB and to make all the operations. So this is the connection. This is how we make a connection to the MongoDB at all. And then since I'm running it on my local machine, I've connected to the local host and the port is going to be static, which is 27017. And I've created a database called as Skill Chatbot and called as Player Dashboard. Okay. Actually, I've commented this part because like for this session, I've already prepared like 1 million records. I've just created a 1 million record and then I've inserted to the database using insert many, which means that there is two operations which can be done. One is inserting the data one by one, like one document by one document. And other option is like you can insert bulk of documents together in a single go. So I've done that, like I've loaded all those data into a list and then I've inserted all those data in a single go. Since this will take some time, that's why I've already prepared the data and I've inserted into a database. So I'm going to visualize this data using the GUI which I've already mentioned, called as Compass. Like one other third-party application is RoboMongo, which is also very useful GUI tool, which helps in viewing the data, retrieving, and making some alterations to the data. Everything can be done with the help of RoboMongo. But for today's session, I'll be showing this MongoDB Compass. Okay, so we can see this all the informations like host is local host and the cluster. Since I've just done it on my local host, it's a standalone cluster. But the real use case or the real purpose of it of the MongoDB itself is to have a cluster of machines to serve the large volume of data and the complex queries. And coming to the this is the DB skill chatbot, and player dashboard is the collection. So in MongoDB, the terms are like say for example in traditional database, the database is going to be database, but when it comes to it has tables, rows, and columns. But in case of MongoDB, it is like collections. We call it as collections, and each collection holds documents. So let me show the documents. So we can see that like there is a 1 million documents, and we can see that like these everything is called as documents. Each one of them is a document. We can show it in a tabular column so that you can relate it very easily. So we can see that like ID, rank, game mode, score, and name. So these are the fields which I already inserted into the database. So ID is it is like a unique key which helps to identify if like we need not write a separate logic to understand if there is any duplicate data or not. This ID actually takes care of that, and it is the default index which is already provided in the MongoDB itself. And let me show you an example like what is the schema free, and what will happen if I'm not going to insert data in this format. So now we are able to see that it holds the same columns and the data is already inserted. But let me do a dummy insert. I'm absolutely sorry, my machine is actually not behaving properly today. Okay, so let me insert this data. Okay, now the data is inserted. So if you're able to see that I did not have this rank or game mode or score or name, nothing I've added. Like instead, it was just pretty straightforward ID and on some junk key and value. So it did not show us any error, but instead it got inserted. And if we do this find operation, we can see that an extra column would have been added. Yeah, you can able to see that like only ID and the CMS string is there. But apart from that, no other data is there. But it not disturb the existing data, and it not even shows any error. So this is one of the beauty of this MongoDB data store itself. So when we talk about this index, let me show you an example. Let me there is an option called as explain schema. What it will actually do is like it will do the query operation, and it will show us like how much execution time it did take, and what all the indexes available, and how many documents it examined. All the information it will provide us. So let me do a random query. I just wanted to name, I wanted to fetch information about a player whose number is 1567. I'm just putting a random number. Oh, this is, so it didn't allow me to do that. Okay. So it took like 29 milliseconds to perform this, because it did went into each document and then it retrieved the data, which took really good amount of time. But in case if at all I'm going to create an index and perform the same query, let's see the difference. Okay. Now we can see that there are two index created. One is the default ID index and next is the name index. Let me do the same operation. It is 2129, and let me do this again. Wait, actually took some time. Not sure like whether it's really had done this operation. But in real time, like it does take some very minor amount of time when we introduce this index. Like it is 2127, and the execution time is 335 milliseconds. Let me do this explain once again. So it is 2005. So the real purpose of having the index is to uh, retrieve the data at a very faster rate, rather than going on searching each and every document in the database. Instead, it will check only on the certain areas to identify and bring in the data. So that is the real beauty of having the index, and it is highly noticeable to create index only on the column which doesn't have any write operation. Rather, it has, if it has more read operation, then it is more advised to have this index created on that column. And this MongoDB Compass provides us various operations. As we see that it shows the query performance, and then we can see the schema as well, like what are all the unique schemas which was created in this collection. And what is the minimum range and the maximum range. Those type of visual representation is also provided by this MongoDB Compass. And let me show you an API which actually I created only for this demo purpose. So as I mentioned earlier, I've used Flask to do that, and I've turned on this Flask server, and it is running on my local host. So I've already predefined text. What it will do is, like I'm asking a question. Can you tell me the total number of players? When I hit this, it is going to tell me like total number of players. Earlier it was only like 1 million, and since now I've inserted one other document, let's see whether it's able to retrieve or not. Yeah, it is like 1 million on one record. And also there is an API wherein I can even do other operation, like I'm asking a question, tell me who are the top 3 players. I think it will display the names of the players who are in top 3 from the dashboard. You can see that it is player 846502 and player 632438, and there is a null value. Probably there is an empty name in that field itself. So that is why we have got this data. And more importantly, actually, I thought of showing like how do we install this MongoDB in our local machine itself. So let me show you actually how I did install this MongoDB in the local system. So it is way too simple. There is an official website for MongoDB itself. You can share those link in the web chat. Since I'm using this Windows OS, I'm installing this MongoDB for Windows. It does support for multiple platforms as well. There is a web page, like in the, if you read this document, like there is an option, like it provides a web link wherein you can download a MongoDB installer itself. I'll show you which I've already downloaded, so that we can reduce the amount of time in searching it. So this is the MongoDB Windows 86 assigned installer, which I've already installed on my machine. And once you start to click this, it will take us to the next option. Of course, the agreement sign up. So those things will be done. And most importantly, 2 things to be done. After doing this installation, you can see that the files will be present in this location. So MongoDB, and we will have the server, and then the version is 4.4, and inside bin we will have this MongoDB. This is the one you need to select it, and then you can see something like this running in the backend. Sorry, this one. So this is how the MongoDB gets started, and from there you can while installing itself, it will ask for an option like whether you need to install the MongoDB Compass. You just need to click a checkbox over there, and that will help us in installing the MongoDB Compass, the box itself. and you can directly open this MongoDB Compass and you can connect to the database. So this is how you can install MongoDB on your local machine.